Hey everyone, welcome back to the Foundations and Pre-Calculus 10 videos. In this video, we're going to look at Lesson 6 from Chapter 4, which is looking at Applying the Exponent Laws. So in grade 9, you learned quite a few of the exponent laws that work with integer bases, or numbers that are whole numbers that can be negative, positive, or zero, and that have whole number exponents. So we're going to quickly recap some of the exponent laws that we learned in grade 9, and then we're going to apply them to expressions that contain variables. So the first law that you guys would have learned was the product of powers. So here we have 8 to the power of m times a to the power of n. As long as you have the same base, you would just add those exponents assuming that you're multiplying the two numbers together. So here, if you have the same base and you're multiplying them, then you just add the exponents. So then your quotient of powers is where you're dividing two numbers where they both have the same base but might have different exponents. Here you would subtract them instead. So multiplying means you add, dividing means you subtract. Then you have a power of a power, so that's where you have some sort of number with an exponent, and then there's brackets on the outside of it is another exponent. So when it's a power of a power, that is where you multiply them. So you multiply your exponents, and then you keep the same base. That's going to be common with all of these here. So you keep the same base. So then the next law is when you have a power of a product. So this is where two numbers are multiplying each other, and then on the outside you have this exponent. So then what you would do is with that exponent is you distribute it to each term. So you get a to the power of m times b to the power of m, and then you can simplify it and solve from there. The last one is when we have a power of a quotient, where here we're dividing two numbers and we're taking it to some sort of exponent. So just like what we did with the product or the power of a product, we distribute this exponent to the numerator and the denominator, and then from there we can go ahead and simplify. So we can use these exponent laws to simplify expressions that contain rational number bases. So working with either numbers, or we can be working with variables there. And then just as a quick note, it's a convention to write a simplified power with a positive exponent. So say if you had an answer that was, say, 2 to the power of negative 2, you would want to take the reciprocal and write it as a positive power. So that's just kind of like our thing is, it's what we call convention. So it's just like writing, we don't write plus 0 or times 1. It's just one of those things that in math we just do that. So now we're going to look at two examples from your notes, and this is example number 2a and b from your notes. So here we're going to simplify the following expressions. So here we have m to the power of 4 times n to the power of negative 2, and that expression is multiplying with m squared times n to the power of 3. So here, what we're doing here is that here we are multiplying. We have that multiplication symbol there. So this one here would be the product of powers law. So if you we can either scroll back up to the top and see what we do here. But with your product of powers here we have to add our variables together. And this here is a really big thing here, is that they have to be the same base. So we noticed that we had two different variables in that question there. So we have to work with just the m's separately from the n's. So if you want to, we can reorganize this. Because we are multiplying here, I can rewrite this as m to the power of 4 times m squared, and then write my n values. So we have n to the power of negative 2 times n cubed. So working with the same base here, so here we're multiplying these two variables, which means that we add the exponents. So this is actually m to the power of 4 plus 2, and then n is negative 2 plus 3. We can go ahead and simplify this. 4 plus 2 gives you 6. So we have m to the power of 6, and then n is -2 plus 3, which is to the power of 1. But we typically don't write to the power of 1, so we can just rewrite that as m to the power of 6 times n. Now we can move on to example B here. So here we have 6x to the power of 4, y to the -3, all divided by 14x y squared. So one thing that's just a little bit of a note before we actually go ahead and start simplifying this is that this squared only applies to the y because there's no brackets. So very important. I see some students kind of get that a little bit confused, but there's no brackets anywhere in our fraction, so that squared value only applies to the y value. So then just to identify what law we're using here, so here you notice that we have a fraction symbol, which means that we are going to be doing some dividing here. So this one here is going to be the quotient of powers. So going up to the quotient of powers, here we're going to be subtracting those values, or so we subtract the exponents. And once again, we have to make sure we're working with the same type of base. So one thing that we'll do is we're going to work with just the numbers separately, we'll work with the x value separately, and the y value separately. So what we can do is we can rewrite our fraction here into just, we can write it based off of their groupings. So we can write 6 over 14 together, multiplying with our x values, so x to the power of 4 divided by x, and our y values, so y to the power of -3 divided by y squared. So we can separate our fraction such that we have our similar bases there. So we're working with the like terms. So working with our first little fraction there, we have 6 divided by 14. And so with that one there's, in terms of our exponent laws, we can't actually do anything here because we're actually not working with a variable. So here we're just going to do some old-fashioned reducing of the fraction. So we want to look for a common factor that's in common with 6 and 14. And that one there, we can reduce this by a common factor of 2. And that gives us 3 divided by 7. Moving on to my next fraction here, I can rewrite this using our quotient of powers. So I can write this as times x, and here we're going to subtract those exponents. We have 4 minus, and when you don't see anything there, you can assume that this here is a 1. So this is 4 minus 1. We can do the same thing here for the y values. So you have your numerator, so -3, minus the denominator, which is 2. Three over 7 is totally simplified, so we can just rewrite that. Then we can simplify our exponents here. So we have x to the 4 minus 1 is 3. And this y here is -3 minus 2 is -5. So while you might think that we might be done here, this is not actually in its simplest terms or in its proper form, because if you guys remember, we should, if we have a negative exponent, we should be writing our all of our exponents with positive values. So what we can do is we can take the reciprocal of this y to the power of 5. So we have 3 over 7 times x cubed times, taking the reciprocal of y is 1 over y, and then that gets to the exponent of 5. We can simplify this just a little bit more. We actually apply that exponent to the 1 and to the y. So we get 3 over 7 times x cubed, and this becomes 1 over y to the power of 5. So while this is an acceptable answer, we will take this one step further, where we can just write this back as one fraction. So here, when we're multiplying with just a whole number, we multiply the numerator and that whole number. So this would be 3x cubed over, then we can go 7 times 1 over y to the power of 5. taking this one step further, we can move our fractions on in here. So 3x cubed times 1 is just 3x cubed. Then we have 7 times y to the power 5. And then here we have a nice cleaned up fraction, and it looks a little bit nicer than what we had above here. This one here wasn't looking so great. This one here looks a lot cleaner, looks simpler, and it makes us a little bit more happier. So that is everything here for this video. So if you guys have any questions, make sure to come see me in class, or you can text me on Remind 101. And thank you guys so much for watching.